there are three classes of levers. A first-class lever is where the fulcrum is in the middle. Teeter-totter, seesaw. If you go down to the playground or any playground, you will see levers, most likely, also known as a seesaw or a teeter-totter. A second-class lever has the fulcrum at one end. A wheelbarrow is an example of a second-class lever. So the person using the wheelbarrow would be standing here. Their hands would be on the handles of the wheelbarrow. The load, the dirt, would be in the wheelbarrow. The fulcrum, what is the fulcrum? What is the fulcrum on a wheelbarrow? Well, that would be the wheels. Third-class levers have the effort in the middle. So when using a tennis racket, your shoulder is the fulcrum. So this would be the weight. The load would be the tennis ball. The shoulder is the fulcrum, and the effort applied would be in the middle. So that is a third-class lever. A little more complicated, and when we study levers more in depth, we will give specific examples of what all these levers are and what they do and where they can be used. Third-class levers: hammers, baseball bats, hockey sticks, golf clubs, tennis rackets. All levers have a load, a fulcrum, and the force. So the three elements of a lever: fulcrum, load, and force. What is the advantage of a lever? A lever lets you change the direction of a force and change the amount of force needed to move something. In other words, you do not need to use your basic human strength and be limited by that if you use levers. Remember that the force is the push or pull that moves the lever. The object being lifted or moved by a lever is called the force. A point where a lever turns is the fulcrum. More examples and a little more detailed discussion about first-class levers. First-class lever, as seen in this diagram. In a first-class lever, the fulcrum, labeled F with a triangle, is placed between the effort, which is the red arrow, and the load, which is labeled R. Effort moves farther than resistance. So the effort being applied, if it were your hand pushing down, that distance moves further than the distance of the resistance. Multiplies the effort and changes its direction, so that this becomes stronger. If you were pushing down on here and you were moving that amount of weight or resistance, you're able to do it with greater force than if you did not have this lever. So it multiplies the effort and changes its direction. So as this is pushing down in the down direction, that's going up. Resistance is going up. Mechanical advantage of a lever is the ratio of the length of the lever on the applied force side of the fulcrum to the length of the lever on the resistance force side of the fulcrum. And all that means is that the amount of mechanical advantage is affected by the placement of the fulcrum. As you move it closer to the resistance, mechanical advantage changes. As you move it closer to the effort, the mechanical advantage changes. Examples of first-class levers, and you see the example here of an experimentation going on, but more something that you're familiar with is we see the seesaw. Here's the fulcrum, here's the effort, here's the resistance. The effort is going down, the resistance is going up, and by moving the fulcrum either closer to the resistance or closer to the effort, that would change the mechanical advantage. We also have crowbars, scissors, pliers, tin snips, All are examples of first-class levers.